This is Geometry 4.6b. Second day that we're going to talk about angle side angle or angle angle side. So we're looking at our given information. We're not going to look at our proof yet. Don't worry about your proof. Don't worry about the two column. Just use the information that they're giving us here. We know that angle G, they have a marker on it there, is congruent to angle B. We also know that segment CB is parallel to GA. Take a close notice, and there are arrows on those two segments. The arrows are telling you that you have parallel sides. What are we supposed to think about when we know we have parallel sides? You're supposed to look for one of these types of angles. And if the picture is drawn like this, we always have alternate interior. That's a very common one that we get. Alternate interior. You've got to draw down the parallel side, then down the transversal, then down the parallel side. You got to be sure you're on the parallels. So this is showing us that we have these angles congruent. So I have G congruent to B. I have my alternate interior angles. What's my third bit of information I know for sure? I have the reflexive property, the one right in the middle. This segment is the same in both of them. So that tells me, even before I do my proof, this tells me my plan is angle, angle, side. I have my two A's and the side that is non-included, that is not in between those two angles. So angle, angle, side. Now we can talk about doing the proof. Now you've studied it. You understand how the result's going to come out. Now we just got to be formal about figuring it out. We have our two bits of given information. So that's the reason where that came from. What type of reason do we put down here? Where's this come from? If lines parallel, I know I have lines parallel as part of my given. If comes earlier, if has to be mentioned earlier, then alternate interior angles are congruent. You're not allowed to say if lines parallel, then angles congruent. You need to be specific on what type of angles. There are 4 types of angles we might talk about with parallel lines. So you got to know what angles you're dealing with. These angles made a zigzag. So they're the alternate interior. What's the reflexive property are we talking about? We have AC congruent. Take a look from this triangle over here, from the A, from the 2 tick mark side, we go up to a non-marked one. So in the other triangle, we're going from the 2 ticker angle down to the unmarked one. So that's going to be CA. So I'm going to suggest here, this is an example when we switch the order of the letters, because the triangles themselves are switched. And then, of course, what we're trying to prove is going to go last. triangle GCA is congruent to triangle BAC. And that was because of the order we've seen it in here. In both triangles, we should have angle, angle, then a side. Angle, angle, then the side. You never write the word proven. Never, never. You always got to give a real reason. Okay, we're going to come down to our next one. We're not looking at what we're trying to prove here. Or we're not looking at the two-column proof. We can look at what we're trying to prove. We can look at the given information. We can look at the figure. Now you need to come up with the reason. What of the 4 ways we've learned are we going to be able to use to prove the triangle's congruent? To prove triangle's congruent, we have to either use side, 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 angle, side, angle, or angle, angle, side. Those are our 4 ways. Which is the correct one for this? Go ahead and talk to your partner, or if you're at home, pause the video, give this a thought, talk to your stuffed animal, tell your gerbil what method you'd use. Okay, let's take a look. Now, one confusing part here, if you take a look at triangle MJN, and we look at triangle NLM, those triangles are overlapping. So when we start to draw tick marks in there, it gets a little confusing when you're crossing lines, talking about things. So I would suggest to draw the triangle separately. That's the blue one with an N, with an M, and a J. And then I'm going to have the green one with an N and an M and an L. Now I can take my given information, J, M, N. That's going to be this angle out here. That's a little tough to find in here, but it's doable. And L and M. That's this angle here. It's a little difficult to find up in the original picture, but it would be right there. Then the second pair of angles that we can talk about. From J to N to M. That means this angle. That's harder to identify here. That's actually this big angle for N. And then we have LMN. That's a little harder for us to show when they're overlapping. So that's why we like to separate them. That was a tough angle to mark. It gets all confusing. What's happening up there? Well, I have 2 angles in one triangle and 2 angles in another. So that's 2 bits of information. To prove triangles congruent, I need to have 3 bits of information. What's the other bit that I know for sure? It might be difficult to see when they're separated, but it's much easier to see when they're put together. The reflexive side, the side where the blue and the orange, or blue and the green are exactly the same. It would be this one right there. So that shows that we have 2 A's and the side that connects them, the side that's in between the A's. So angle, side, angle. So now you've studied your picture. Now you've made a determination of how the triangles are congruent. Now you're able to start to try to fill out your proof. Don't worry about this picture down here. We're not using this picture right now. So we know that angle JMN is congruent to angle LNM. And we also know that angle JNM is congruent to angle LMN. We already labeled those in our pictures. We have to put that in our proof. It's always a given. Where did this come from? What is this implying? That's our side that we didn't know from the given. That's our reflexive property. Now, I would suggest if we use NM for this first triangle, from the 2-tick angle to the 1-tick angle, we should go from the 2-tick angle to the 1-tick angle. I would suggest to write that in the opposite order. I would write NM. Did I say that wrong? MN. Okay? But it's not a deal breaker. It's still the same segment. But just to let you know, when we switch them, when we don't, this would probably be a time we would switch them. So if you want to switch it in here, that would be appropriate. Okay, and your last reason, notice what we have here. We have two A's, and we have the S. We've talked about two pairs of angles congruent, and we've talked about a pair of sides congruent. Now you've got to be careful. This almost looks like angle side. It's just the way the information we were given. We have two angles and the side in between. That's the real reason. But you know it's going to have to do with two A's and an S. Angle side angle. Because of the order in the picture where the angles and the side is in between. And of course I should have written my triangles in here. MJN is congruent to triangle NLM. And that's our proof. Two more to work with. Now this one, it's a little trickier. This would have been the picture that came from the other side. Now I know that we're going to work with AED. And BEC. In the other picture over here, they're showing us extra lines. You see that? Showing us extra lines. We don't need those extra lines in here. I'll kind of lightly put them in there. But sometimes it really helps you to break it down to understand what parts do you need. Since we're working with AED, we're not going all the way down to C for our triangle. That would be a typical way to do it. Or maybe we're working with the triangles that went all the way up. So this picture could be used for many different proofs. We're using these triangles in here. So again, not doing our proof. You're going to work on trying to come up with which method, side, 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 angle, or angle, angle, side, are you going to use to prove these two triangles congruent? Use the given information to prove these triangles congruent. Just come up with the method. Mark your figure with all the appropriate markings, and then give the reason, one of these four, for what is the correct way to prove the triangle is congruent. Pause the video and work through that. So we're coming back. I see that AE is congruent to BE. We did not know that. We had to look at the given information. So you should have those tick marks drawn on your figure. Angle ADE, A to D to E. Do you understand that the vertex is the middle letter? So we're talking about that angle right here. When we use three letters and we're naming an angle, you can trace it in the order of the letters that they have, and that's an angle. And then BCE. That's this angle. Now that's two bits of information. That's a side and an angle. So I could be working with side, angle, side. I could be working with angle, side, angle. Or I could be working with angle, angle, side. Which method am I going to use? What's the other piece of information that I know positively is the same? If you look at the big X, this little intersection here is a corner of the triangle we're working with. So these are vertical angles. So I know that these vertical angles have to be congruent. Now I have two A's and the non-included side. Two A's and the side that's not in between the angles. Two A's and the non-included side. So that's the way I'm going to prove the triangle is congruent. Now you might be ready to do your proof. You have to make the marks on your figure first. You've got to come up with a plan or a direction where you're trying to head. We've already talked about one pair of sides, so we have an S taken care of. We have an angle already taken care of, so that's pretty easy. That was all part of the given. But what's going to go here? Should not be a surprise. I think everybody in here should know. This says vertical angles are congruent. I feel that it's missing something. This should say if vertical angles, I'm going to rewrite this, if vertical angles, that is true in the picture, we have vertical angles in the picture, if vertical angles, then congruent angles. I know that's pretty much what this says, but we like to write them in if-then form whenever possible. So we're talking about our vertical angles. AED. Angle AED is congruent to angle BEC. Your last statement is always what you're trying to prove. Triangle AED is congruent to triangle BEC. And we've already determined that the order that we know it in is angle, angle, side congruence. So now we have our last one. Don't worry about the two-column portion of it. make your tick marks on it. Figure out which of the 4 methods that we're going to use for this. Pause the video and give that a try. So, looking at our information, we know ST is perpendicular to TW. You got to use your eyes. So, what notation do I put on our figure? What does that mean, perpendicular? What notation are we going to use? I'm going to put a box in the corner where ST and TW come together. We're also going to put a box. This is perpendicular. That means the sides make a right angle. VW, WT. And we know that right angles are congruent. So that's good enough for an A right there. Angle VTW. V to T to W. We trace out that angle. VTW. That's this angle right here. Congruent with SWT. That's this angle right there. So we have 2 A's involved so far. What's the third bit of information we know for sure? We should all be able to do this by now. What's the third bit of information? The reflexive side. That's the side both triangles are sharing. So that segment is going to be congruent. Yeah. So angle, side, angle. So let's come down and try to fill in our proof. It's very nice. They filled it in for us for the given. Now what's this mean? Where did this come from? What are we going to say? Why does this happen? If perpendicular, if 2 segments are perpendicular, then they form right angles. So if perpendicular, then right angles. You could say right angles are formed. That would be excellent. You could look at your wording for proofs. So we're looking for if perpendicular, then right angles. If 2 lines are perpendicular, then they form right angles. You could use all those words if you want. I'm showing you a shortcut that you could say if perpendicular, then right angles. It's about as short as you can make it. So you can use this sheet to help you get the wording right and look for options. Now, what's this trying to tell us? What's it expecting over here? Looking on our sheet, if 2 angles are right angles, then they are congruent. That's what they're trying to tell us here. Right angles are congruent. If comes earlier, we already said they were right angles. If right angles, then congruent angles. This isn't really the correct wording. That would be the best wording. So what am I going to write down as my right angles being congruent? Everybody in here knows. Angle STW is congruent to angle VWT. They are the right angles. The reflexive side. Going from the 90 degree down to the angle tick mark, we got TW. So TW. From the 90 degree to the 1 tick mark, we got WT in the other triangle. So that's why I'm labeling those in a different order. That's a reflexive property because that segment's in both triangles. We know that triangles are congruent because of angle, side, angle. We talked about angles being congruent. We talked about sides being congruent. Well, that's not sides, those are angles. And side. Now, the order in which we prove it is not always the order in which it shows in the picture. We need to pick the order that's correct in the picture. Angle, side, angle, the included side.